Hey guys, welcome back to Codance. We are doing POTD. We're solving POTD. Let's see what is the problem of today. Sum of distances, okay? ARR of I is the sum of absolute value of I minus j over all j such that, okay, and I not equals to j. Okay, there is such no such j, set ARR would be 0. Okay, okay, okay. Sum of j minus I over all j such that this condition is true. Okay. So, like if you take this and this, j minus I minus j or j minus I would be, I think, 2. Mhm. Yeah, yeah. Oh, sum of I minus j. Okay. Let's try to see. 1, 3, 1, 1, 2. So if you see for the first element, we can see that the second and third indexes have 1 and 1. So the first index, it would be 2 plus 3 is 5. There is no, so it will be 0. For 1, again 2 plus 1, that is 3, I think. Yeah. And for another 1 plus 2. Yeah. Wait. This is 3 plus 1. Yeah. 3 plus 1, 4. And next index. Okay. So we should require a map like value versus its indexes, and we are going to like with that index how much distance. Okay, yeah, so for one we would store like 0 2 and 3. With 0, how much distance? With 0, with 2, with 3, we'll get the answer. We'll store it in the array. For 3, there is no, so we'll store 0. For 1, that is second index. Okay. With 2, how much distance? It would be like 2 plus 0 plus, I think. Uh, no, it's 1, 3. Similarly, for 3, it would be like 3 plus 1, 4. And rest is fairly simple. Why vector long long? I don't know. Call it add only. what we will do? We will move on, iterate over nums, and we do record a map value indexes. Hmm. Okay. Eh, wait. Yeah, it makes sense. It will be found now because we have pushed it. There is no such index, it would be zero. So 3 minus 3, okay, makes sense. Uh, but it should store vector of int. Yeah. And what you should do, we should, okay. So yeah, we have map with that index. Okay. We'll have the answer. We'll add that I minus here. Hmm, X comma Y, I think we can use maybe. Y is our second and X is our the number. I don't think so. We require this. Rather, we should do like nums of I and we call it Y. Sorry for the inconvenience because I'm little bit ill. Uh, what I should do? We should absolute of I minus Y answer plus equal. We'll add the what absolute value of the like I minus Y, the indexes that we have. And we should push it to like return ARR maybe. Let's see. It fairly work. Oh yeah, I've been using this short forms for I think there may be TLE can be because yeah, because of these two loops. Huh? Runtime error? Okay. Long, long. What happened? What is happening? Yeah, so it showed a TLE because obviously if all elements are same, then map will insert it like the size of map would be n, I think. And so we are moving like n times through each elements, and obviously we are moving here also n times. So it would be a TLE because 10 to the power 5 into 10 to the power 5 is 10 to the power 10, which is not feasible for our constraints given. Okay, so what should I do? I thought a bit and got some idea. Let's try it out. Okay, the idea was if I just move from the in the forward direction. Okay, so I will insert like one. So one first, zero. So we didn't find anything, so it would be zero till now. We didn't find three till now, so three would be zero. For one, again we got one. We found one in the index zero. So 2 minus this index would be 0 minus 2 index would be 2 minus 2 absolute would be 2. Then we do have found the uh, 0 with 0 and 2. So we should minus like with 3. So it would be like 3 plus 1, it is 4. And 2 we didn't find, so it would be 0. From backward again we should come. Okay, we should make it 0 first, 1 because obviously you can't find anything before that. So in the when we go backward, we get 1, so it would be 4 only, whatever it is. Okay, whatever it is, it should be that only. And for again 1, we do have found it before, that is at 3. 3 minus 2 would be 1. 1 we add 3 plus 2 plus 1 is 3. Okay, then 3 can't find it, so whatever it is, it would be that. And we do have found it, the index backward, so should be 2 plus 3, that is 5. So we got the answer added. Now need to think whether it would be a TLE or not. So think of all the elements are same. Okay, so for each indexes, at the last index we need to all the n minus 1 elements. Okay, so for 0 there is 0. For 1 need to find 1. Maximum, worst case, n minus 1. Okay. N minus 1 elements you need to check whether there is any elements or not. Yeah, for 1, 2 it is 1. माइट बी टीएलई हो सकता है टीएलई हो सकता है hmm or maybe not because you are moving in one direction. Hmm, let's try it out. What I thought is that so I will start from 1 only. MP of nums of 0. Yeah, we should store it as no, it would be overwritten if I just store it. Will I not get it from the previous stuff? Let's see. Yeah. Uh, 1, 3, 1, 1, 2. First one would be 0 only. Okay. Second one, that is 3. Since we can't find it, the map should be 0. And we insert it with 0. We move on to the uh, again 1 we found. And we found 1 at a 0 best. So it would be 2. Again found 1. What we should do now? It should be uh 3 plus 1. Yeah. Recently found an index 2, but previously it was 0. Does it make sense? Hmm. But we stored the value 2. 3 minus 2 is 1. 3 minus 2 is 1. But we also require the previous index that we have found it. Hmm. Hmm. 2 a little bit confused. I think we can do it. Hmm. 2 plus 2 is 4. But with 3 plus 1. See, we are index 2. And if it is 2, we minus it 2 minus that whatever that index is. Okay. Um. So we get like 0. Taking space is not a big problem, but time is a very bad thing. You should not, like, for the user, time is very important. So that's why we're getting the index ID. Uh, hmm, I don't know. I really don't know. Uh, is a vector, and we should add what? I'm using I, J user. We should add the yeah. It's only indexes that we have found. Okay. Uh, hmm. Then we thought, let's clear it. Now we thought कि n-1 एलिमेंट को पुश अप कर दे. Greater equal 0, I minus minus obviously. Okay, here goes to 0, I minus minus. If we can find it, obviously we should move on. It's with its vector, and error of I would be uh whatever that index minus where Do you have find it already? Uh, what happened? It's returning. Hmm. Uh, 2. Yeah. Then I think 3 plus 2. I think we didn't push back uh, the elements here, I think. Okay. I think here we should. Oh, n minus 1 से नहीं 2 से I think 2 से स्टार्ट करना चाहिए कि 1 वाला तो हमने कर ही लिया 0305 nums of I that's why I told you na I'm a bit ill. Wait. Why did I push this? 0. Should be n minus 1, nah. I don't know, maybe TLE also. Because I can see a problem. But let's see what happens. Because this is again running n times for the last element. Yeah, it is going to be a TLE. It is going to be a TLE. We need better optimizations. Something which will be helpful for like big of n, like prefix or something, prefix sum or let's see, let's think of it. Like best we can find for this index is 2. So for this index, it would for the next index, it would be 3 plus what? Plus okay, so we know this index. Yeah. We should also know the previous index, huh? Okay. And the previous index is think 2 along with whatever the best we got. So we got best as 2, 2 plus the difference that is 1, 3. So 3 from previous indexes like yeah. So think कि बहुत सारे ऐसे same numbers है. So हमारे पास like we found lots of same elements for that index we found the best from all the indexes. Okay. For this index, let's say it would be like what? Best is what? Um, 1 plus 2 plus 3 plus 4. Yeah, 10. So for example, I'm doing where we are getting like 10 as the best that we are getting. But for now, for the next index, it would be 11 because see, uh, 11 for all this stuff. 2 plus 3 plus 4 plus 5. Okay. Hmm. Best will be different, I think. Plus 1 correct. Hmm. Wait. 4 तक तो ठीक ही था. I should also require a like how many times everyone will be added na by 1. So 4 will be added. Okay. Yeah. So 4 will be added to get a sum of 14. You see 2 plus 3 plus 4 plus 5 is 9 plus 5. It is 14. Make sense? So base that we can get is number count number of times it came before and base that we got from there we'll get that plus the okay so we do require the index. Okay, index base that we have got and number of such elements that we got, so it's a tuple. The index is very much important so that we get the difference. Let's say there is no, we can't find same element for, let's say we found it here. So should know the index where we found last. Okay, the same index. So it would be the difference 2 and then how many elements are there. Okay. Okay, so yeah. So count will be how many such elements that we got. So count is very important, index is very important, and the best plus count multiplied by ABS of I minus IND. Make sense? So this will be the answer so that we do not need this loop which can go big of n or big of n at max for let's do it again. We are going to store uh, int comma tuple int index best can be long and count. Okay. 0 for zeroth element np dot uh okay mp of nums of 0 is a tuple. I think we should do make pair or something. Let's not think about it now. Okay. Uh in what? Index. That is 0th index. Best ARR of 0. Uh int, that is count. 1 if mp dot count nums of I, that is found. If it is found, ARR of I is going to be um wait, if I know the index, do I require this thing? Because we will get that from the ARR of that. Yeah. So pair of int comma int. If I know the index, okay. So what is the formula? Best, that is ARR of okay. Yeah. So auto, let's call it index comma count, है ना, is going to be um mp of nums of I, okay, and it would be ARR of index plus, okay, count multiplied by abs of, yeah, abs of I minus index. Okay, okay. Yeah, mp of nums of I should store the index, comma, uh, nums of, okay. So we need the previous, okay, so we can just, hmm, okay. If it is not found, we should push, okay, okay, makes sense, makes sense, makes sense. We should push it here, na? Plus one, okay. MP of nums of I should store the new index. The last index that we called count plus one. Else, that is not found. Error of I, whatever it is, it would be remaining the same, and we should uh I comma 1. Hmm, let's see. Should work for the forward loop, but we should require a backward loop also. Yeah, yeah. It's completely Nicely we done it. Now let us do it with for the backward loop also. For the n minus one element, we should we require the n minus one index and obviously one count. Okay, yeah, and clear that first of all, to clear that because previous element were that, but we need new fresh one to be put in nums. Then we count it. Sorry, whether it's found or not. Okay. Zero minus minus. Um, yeah, MP of nums of I. Okay, it's the same thing that we did in the previous window. What? Huh, what? Wait. So in the forward loop, it is good, and the backward loop, it's not. Hmm, found. Oh, okay. Yeah, backward we didn't think. We didn't thought a bit also for the backward and stuff. What will be the for backward? Yes. For forward, we got like 0, 0, 0, 0. Uh, what we did got? Let's see. 2, 4, 0. So in backward, what you should do? Whatever array it has storing, it should be remaining the same. Um, we'll see whether we found it or not. Obviously, we can't find it. So it will be 4 only. And it's storing like index 3 and count is also 1. For this index, what we should do is that we should add 2 plus 2 plus 1. Nah. So it should be 2 plus 1, 2 plus 1, 1, 1. Hmm. Okay. For this, it would be like found okay 0, 0 plus okay 0 plus found last index at 2. 2 minus 0 is 2 multiplied with its count with number 2. It is 4, but it should be 5. I think we should store the previous index only. है ना? ये सबसे पहले जो मिला था what was that? It's like 1, 2, 3. 3. Hmm. 3. 3 into 2 is 6. Mm, Hmm, let's think a bit. Bro, this is very much chill. But let's see. 0, 0 plus what should we do? Um, 2 plus 3, na? So, hmm, uh, wait a bit. Hmm, I'm little bit, I'm trying to change some stuff to check whether it's correct or not. I don't know actually. Two, 2, 3 plus 2, na? अबे यार 3 plus the index difference, that is hmm, I'm counting bit too much, na? Wait, what was before? Before it was 2, what we require? 3. So 2 plus the difference is 3. Yeah. Um, for this index, uh, what do we have got? It's like before we got like 2. 2 plus 2 is 4. Mm. Okay, okay, yeah, yeah. So 2 into 2 is 4. Okay. Wait, 2 plus 3. Okay, we do require 2 plus 3. 2 plus 3. We do know. 3 is the best that we can get up to this. 3 plus 2. But for this, it's not the same. 2 plus 2 is 4. Bit confused. Hmm. Should we do with another array and add both of them? Will it work? I don't know. Let's try it out. For 2, let us say it's a 0. For this element also, let us say it's a 0. For the previous element, it would be 1. 1 plus 2 into 5. Okay. So I think, yeah, we make another array and we should do this. And at last we should, what should we do? Huh. Okay, let's submit it out. Though again, TL is not a good thing. Wrong answer. We're getting now wrong answer. Hmm. Hmm. Obviously for the forward, it's going to be the same, but for this, it's giving like a 10, but it should be 7. Okay. From forward we got the west. Backward it should be like +1, something like this. I don't know actually. Okay, so yeah, 4 plus 3. Yeah, Okay. Sorry, sorry. Um, okay. It's accepted. Nice question, I would say. It's bit using a formula, and it's taking like big of n at max. Okay, time complexity. Let's see what the solution it gives. Prefixum hash map. Okay, yeah, prefixum. We're using a prefixum, na? Yeah, hash map also we are using. Okay, it's very clean, I would say. Yeah, okay. Result. Okay, okay. We move to groups. अच्छा इसने थोड़ा सा hmm the vector I think we calculated the total, okay, and prefix total, okay, move to each hmm yeah, if it is like groups dot size is where n, then it would be like running for one index only, so it is running for n only. If it is like what n, if it is having one element, then it is going to be n. Okay. So big of n times only it will run only big of n times, and there is some formula that it used. Okay, race of groups of I. Okay. Mm-hmm. Uh, Total minus prefix into 2 I minus n. Something, some formula that they used. Yeah, we do not require this thing. If you don't want to go into that math stuff, you can do this thing, which is fairly simple, I would say. The forward loop, we just move to forward loop, and we, if we can find it in the map, obviously we just get the indexes and whatever the best we got into plus count number of times we got it, and the difference. Okay, so obviously for this the best would be this difference plus this. So we know the best from this all the indexes. So if I just uh, multiply count number of times and difference, so it would be like added like count, so what count into something what it gives, keep for each indexes difference would be like for say, for example, let's say four number of elements that we you previously got, and we are getting the best, we got the best from here, so we will get the best from here, and the difference will get me the this much, but we need all the differences, yeah, added up. That's why you just do it. If you want, if you do it in your notebook, it would be very helpful, you understand it more. Let me do it. Let me tell you again. So let's say we got one at zeroth index, one index, second index, third index, and we are finding third for third index we got answer best. Okay, so we are at, let's say, fourth, fifth, sixth index. Okay, we know the third index best from array. Okay, we stored pair of int comma int is like index and count number of, so it's like four times, and 4 into, what is the difference? 3 minus 3, bar 12. So if you see 3 plus 4 plus 5 plus 6, what is, oh, wait, 3, okay, 3 प्लस थ्री प्लस थ्री कितना टाइम्स होगा? कितना टाइम्स होगा? इट इज काउंट नंबर ऑफ टाइम्स, हमें इतना डिफरेंस आगे बढ़ना है, तो बेस्ट प्लस count into the difference that we got. Okay, this is the difference. This is called the difference. Make sense? And why do we did it for backward also? We need the same thing, and we just added both of them to get the correct answer. Simple. Hope you like this video. Like, share, subscribe, and comment. Uh, I think we should do a challenge of doing some this POTD for, let's say, 30 days or 60 days. Let's see how many days we can do. Thanks. Bye.